Saxon Advanced Math Lesson 11C. This is the quadratic formula. Now, I want to start with just a few things first and where the quadratic formula comes from, and then we'll get into some application in just a moment. We already know how to complete the square. If you don't, you need to look back at one of the other videos that I've made on completing the square. I will go over it very, very quickly here as a review on completing the square. If I was given this as my problem and told to find x or to factor this if I wanted to do either one, I could use completing the square. Now what I would do to start with is I write it out and I divide everything by 2 because in order to complete the square I needed to have the a value, the first value, to be 1. And when I divide everything divides by 2, which is nice. It leaves me with this right here. I move the 6 over to the right hand side. Once it's over there, remember that a perfect square trinomial works that way because half the middle term squared is the third term. So half of 1 squared would have to be 1/4. And if I were to pick this problem out, I'd make every trinomial into a perfect square trinomial because it works to factor so easily. So what I do is I take 1/2 of 1 and I square it and I get 1/4. But if I add 1/4 to this side, remember I have to add 1/4 to this side. When I do so, I go ahead and say 6 needs a common denominator, so I multiply the top and the bottom of that by 4. That gives me 24, and then add it to 1, that gives me my 25/4. Remember that this is now a perfect square trinomial, which means that half the middle term squared is the third term, which means it is 2 of the same binomials being squared. So those binomials are x minus 1/2 and x minus 1/2. And once again, that's because I made this into a perfect square. Now I have x minus 1/2 squared equals 25/4. If I take the root of both sides, I have the root of 25 over the root of 4. This is important to remember. I have to put a plus or minus in here because, for instance, the root of 9 could be 3 or -3, and the root of 25 can be 5 or -5, and the same thing with the root of 4 being 2 or 2. I don't need to put it in the plus or minus twice because obviously there's only 2 options, and if I had 2 and 2 I'd have 4 options, but they would reduce down to 2 unique options anyway. So at this point I do 1/2, my x minus 1/2 equals plus or minus 5/2, and I move the 1/2 over to the right hand side by adding 1/2 to both sides. I need a common denominator, but I already have one, so I can add these up and say 1 plus or minus 5/2. 1 plus 5 is 6, divided by 2 is 3. 1 minus 5 is going to be -4, divided by 2 is -2. These are the roots, or the answer to this problem. So if I'm looking at this here, I'm saying what are the roots? They're 3 and -2. Remember that in order to factor with this method, I would then put that back into the x minus. So it would be x minus 3 and x minus a -2, or x plus 2. So my factored value for this would be x minus 3 and x plus 2. That's my completing the square method. If I did the same thing as this, but I put in, instead of values here, here, and here being constants, if I assign those a, b, and c, and this is where this comes from, I assign these any values of a, b, and c, I can line these up and say, well, if a exists, then I need to get rid of it, much like I did here. I divided by 2. I divide everything by a. When I do so, it cancels the a here. I end up with b over a and c over a, and that still equals 0. This is looking better because now I'm going to move the c over a to the left or the right hand side by subtracting it, just like I did over here. Now I have this set up and ready to go for a perfect square trinomial, but I need to create that perfect square trinomial. Once again, in order to create it, it's half the middle term squared. Well, half of b over a is b over 2a. Just like I did over here. So b over 2a. And then I square that and I get b squared over 4a squared. But once again, if I'm going to balance this equation correctly, I need to have a b squared over 4a squared added to the right hand side as well. So I slipped it in right in here, and you'll see why that is in just a minute. One, it keeps everything nice and positive for me as a leading coefficient. The next thing I do is I factor this. This looks horrible. And normally you would look at it and say, well, I don't even know what to do with factoring this, except that you made this into a perfect square. You know that half this middle term is this term because you set it up that way. So half of b over a is b over 2a. b over 2a plus x, or x plus b over 2a squared is what this is. And if you don't believe me, work that out. That works out nicely. And the only reason it does is just like on that side when we completed the square, we made it into a perfect square. But then I go ahead and I find my common denominator over here by multiplying the top and the bottom of the second term by 4 over a, or 4a over 4a. Remember, this is just a fancy version of 1. And that leaves me with a common denominator that I can add to b squared minus 4ac over 4a squared. Once I get to this point, I'm ready to take the root, just like I did over here with taking the roots. And so I take the root of this side, and I end up with x plus b over 2a. And this ends up with a plus or minus the root of b squared minus 4ac over the root of 4a squared. I can't do anything with this one, but I can this one. There is a square of this. The root of 4 is 2, and the root of a is squared is a, and that ends up with a 2a. I'm really close here to having a formula that I can use and derive this way. So when I say plus or minus, I went ahead and use my common denominator, and when I do, I'm left with negative b plus or minus the root of b squared minus 4ac over 2a. This is known as the quadratic formula. Why is that so useful? Well, at this point, you're looking at it saying, that looks a lot worse than anything I've seen. Why would I want this? This formula allows me to find the roots, even if the roots are imaginary. I can factor any trinomial by just identifying. And this is the method that I mentioned in other videos with encapsulation, if you're following through the series here. And what that means is if I could just make it look like this, I know that this is what x equals. I don't have to do all this in the middle again. If I could just get it like this, if I could identify my a, my b, my c in a trinomial, I could stick it into this formula and it would tell me every time what x is. Let's watch that happen with this same problem. So I took this problem, I put it over here. I identified, well, in this format, a stands for 2, b stands for negative 2, c stands for negative 12. And I would suggest when you're working these problems that every time you write out what a, b, and c equal. This will help until you get to where you're doing this on a regular basis. This will help you to identify where they go. Then I use this by putting them in, making sure that I have parentheses where needed. So in other words, the negative b, well, my b has a negative, so it's a negative, negative 2. That's my b. Plus or minus the square root of b squared. b is negative 2, so I plugged it in. Minus 4, that's part of the problem, right? Part of the equation. Times 2, because that's my a value. Times c, which is a negative 12. All this is over 2 times a. Well, a was 2. Now I have a form of my equation that's ready to go that I can do simple math with instead of having to find the perfect square, add that, common denominators, move it to one side or the other, take the square roots of, and then add the plus or minus. This allows me to do all of those steps in really just a few. So once I get it to here, I start simplifying. Negative 2 squared is 4. Negative 2 is positive 2. A negative 4 times 2 times negative 12, positive 96. 4 plus 96, 100. Well, this one works out nicely. The root of 100, I know that one, that's 10. Okay, so I'm ready to start just moving this down. And notice that I'm not doing anything with higher or level algebra anymore. I'm just simplifying at this point. So I take the root of that gives me 10. And I say 2 plus 10 over 4. Well, 2 plus 10 is 12, divided by 4 is 3. 2 minus 10, negative 8, divided by 4 is negative 2. And look at this, I have the same answer, but I had to do less thought because I have that formula memorized. Memorizing this formula sounds hard. Figure out a way to do it because you will use it throughout your algebra with factoring, and in later lessons in this book, we'll use it extensively. This also allows me to take numbers that are imaginary and come up with imaginary roots for trinomials. Look, this is from the problem set 11. This is a part of the homework on this, number 9. And I went ahead and put this up here just so you could see this one was very simple and it worked out nicely. What happens when it doesn't work out nicely? So 3x squared plus 2x plus 5. And if you wanted to go ahead and just factor this, and that would be the biggest pushback I usually get from students is, well, I can look at that and factor it. Why would I want to go through that huge formula? Well, there's your challenge. Look at that and factor it. Unfortunately, I can't factor that in my head, and I don't really know anyone that can. But I am going to go ahead and use the formula because I know it works every single time, and I identify each one of my variables. A is 3, B is 2, C is 5. It's as simple as that. I then plug in the formula that I already know, right here, and I start plugging in my values. Negative b plus or minus b squared minus 4ac 2a. Once I do that, I start working these out. 2 squared is 4. Negative 4 times 3 times 5, negative 60. This is where it gets interesting because 4 minus 60 is not a positive number. It ends up as a negative 56. And now I have an imaginary number, right? Because the root of a negative number is imaginary. So if I start reducing this down, I end up with 56. Now I admit something here. I don't work roots real well in my head. I still have to write out the little tree. Take 56, divide by 2, and get 28, 2 again, you get 14, 2 again, you get 7. If you've never seen one of these little trees, it does help with simplifying your roots. I circle my pairs. There's one set of 2's that can come out, and I do so, leaving with a 2 and a 7 under the root, and I put it in there. However, I went ahead and substituted, instead of this being a negative root, I put the I in there. Remember, I stands for the root of negative 1, and I can always pull that I out to the right. When I do so, I end up with negative 2 plus or minus 2, root 14i over 6. Now, because these terms both have 2's in them, and that's reducible by a 2, I can pull the 2 out of here, here, and that's 6, and reduce to the 3. Negative 1 plus or minus the root of 14i over 3. Now, anytime I'm working with imaginary numbers, remember the customary way to write the answer is real plus imaginary. So I'm going to go ahead and split those into the two fractions that exist, and this is going to be my answer. This is the roots of this equation. I could even come up with the factors of this equation, which is a later lesson, which we'll come to. But this allows me to come up with an answer that is a factored root problem using completing the square without having to go through all the pain of completing the square in the middle. So I can just apply a formula and it works every single time.